Quadratic equations. Our objectives are to factor a quadratic equation to solve it, use the square root property to solve a quadratic equation, complete the square to solve a quadratic equation, use the quadratic formula to solve a quadratic equation, and use the Pythagorean theorem and the square root property to find the unknown length of the side of a right triangle. What is a quadratic equation? Well, a quadratic equation involves an x squared and nothing more complicated, like an x cubed, square root of x, and so on. To solve quadratic equations, we can use factoring, the square root property, completing the square, or the quadratic formula. Let's practice some factoring here. Factor 5x squared minus 16x plus 12. Well, I don't see a greatest common factor, so I'm going to go ahead and make my framework of parentheses so that I can break up this polynomial. Let's try with a 6 here and a 2 here. This would be a negative 10x and a negative 6x, and we have it. Here, an x squared plus 2x minus 120. I don't have any greatest common factor to take out. So I'm going to go ahead and break up my polynomial into these two parentheses. X and x makes the x squared, and I have a negative in front of the 120, so I know that I'm going to have a positive and negative. Since I have a leading coefficient of 1, I want to make sure I find factors of negative 120 that add up to be 2. And those numbers are going to be a positive 12 and a negative 10. For our last one, I have x squared minus 2x plus 2. If I try to factor this, again, since my leading coefficient is 1, I'll need factors of 2 that add up to be negative 2, and there are no factors like that, so we'll just write prime for now. We'll have to deal with this with a different method when it comes to solving an equation that involves a quadratic like this. Now, the whole premise of being able to solve a quadratic equation by factoring is based on the zero product rule. Solving by factoring depends on the zero product rule, which states that if a times b equals 0, then this is a unique case. It means a equals 0 or b equals 0, where a and b are real numbers or algebraic expressions. So now let's practice solving by factoring. Solve these equations. The first one, 12x squared minus 28x equals 5. For us to start factoring, we need to have everything on one side equal to 0. So I'm going to subtract 5 from both sides. Now, when I factor this, using whatever method of factoring you want to use, we'll have 6x plus 1 times 2x minus 5 equals 0. Now, the zero product rule says that if this times this equals 0, then it must mean that 6x plus 1 equals 0, or 2x minus 5 equals 0. So now I can solve each of those easier linear equations. 6x equals negative 1 gives me x equals a negative 1/6, or 2x equals 5, dividing both sides by 2, I get x equals 5/2. With our next example, we start out the same way. We have to have everything on one side equal to 0 so that we can factor. Here, we do have a greatest common factor of x. So I'm going to take that out, and I'll have 5x minus 6 equals 0. Now, x equals 0, or 5x minus 6 equals 0. Solving each of those simpler equations, I already have my x equals 0 solved for, but 5x minus 6 becomes 5x equals 6, and x equals 6/5. So I have my two solutions for my quadratic equation. Now let's look at solving using the square root property. When there's no middle term in a quadratic equation, the square root property can be used to solve it. Let's solve the quadratic equations using the square root property. What we do is we try to isolate the squared thing. Right here is my x squared, so I'm going to work at trying to isolate that x squared. Dividing both sides by 2, I get x squared equals 9. And then I can take the square root of both sides. So x squared equals 9. I'll take the square root of both sides. And remember, since we have put the square root on there, we also have to put the plus minus. So x is plus or minus 3. You can also solve this one by factoring, and you would get the same answers of plus or minus 3. Example B, I have x squared plus 20 equals 0. Let's try this with the square root property. And now I'm going to take the square root. Remember your plus minus. And x is equal to plus or minus. Remember, our 20 breaks up as 2 times 10, 2 times 5. So I'm going to take 2 of the 2's out, and that becomes a 2. We were taking the square root of a negative, so it's I. Square roots of 5 is left inside. Another method we can use for solving quadratic equations is by completing the square. Now, you remember we did completing the square when we learned circles. If you want a review of that, you can go to the circles section. We can use that for solving our quadratics using this method. So to solve ax squared plus bx plus c equals 0, where a is not equal to 0, using completing the square, we first need to make sure that a is equal to 1. We're going to get thrown some problems where a might be another number. So if a is not equal to 1, we'll divide each side of the equation by a to force our lead coefficient to be 1. Then we'll rewrite the equation so that c is alone on one side of the equal sign. Complete the square, making sure to balance on the other side. We'll factor the resulting trinomial as a perfect square and combine like terms on the other side. Then we'll use the square root property to complete the solution. Solve by completing the square. 3x squared minus 6x minus 5 equals 0. The first thing that we'll want to do is go ahead and isolate the variable terms. After this, we want to divide both sides by 3 so that my leading coefficient is now 1. Now I can complete the square. Half of negative 2 is negative 1, and negative 1 squared is positive 1. So I'll add 1 to both sides to keep it balanced. And then I can write this as x minus 1 quantity squared. On the right side, I go ahead and make that an 8/3. Then I can use my square root method after that. Remember, put the plus minus when you're taking the square root so that you capture all solutions. This gives us x minus 1 equals plus or minus square root of 8 over square root of 3. I'm going to go ahead and rationalize the denominator here. This is going to give me x equals 1 plus or minus the square root of 24 over 3. The square root of 24 is the square root of 4 times 6, so I can write that as 1 plus or minus 2 square roots of 6 over 3. For b, I have x squared plus 3x plus 25 over 4 equals 0. Now, my leading coefficient is 1, so I don't have to divide both sides to start this problem off. Isolate the variables as usual by subtracting 25 fourths from both sides. Then I'm going to take half of 3, which is 3/2, and square it and put that number here. That's 9/4 that I'm adding. But remember, we have to add 9/4 to the other side as well to keep our equation balanced. Now I'm ready to factor the left side. So this is x plus 3/2 quantity squared. And on the right side, I'll have a negative 16/4 or a negative 4. Now I'm going to take the square root of both sides, and don't forget your plus minus. So then I'll have x plus 3/2 equals plus or minus 2i. Subtracting 3/2 from both sides so that I have my x completely isolated is negative 3/2 plus or minus 2i. The solutions here. Now that you've had some time to solve by completing the square, let's see if we can solve this ax squared plus bx plus c equals 0, the general quadratic equation for x. So just like we started out, we're not sure that a is 1, so we need to divide a, both sides, and I have x squared plus b over a x plus c over a equals 0. Now I need to isolate my variable terms, so I'm keeping my x squared and my b over ax on that side. Leave a space so that you can complete the square. Subtract c over a. Now I'm completing the square. I take half of b over a and square it to put that here. Half of b over a is going to be b over 2a, and b over 2a squared is going to be b squared over 4a squared. Don't forget, we need to balance, so we add b squared over 4a squared to the other side as well. Now I'm ready to factor the left side. I have x plus b over 2a quantity squared. On the right hand side, I should be able to get these fractions together. I just need a common denominator for my fraction. So I'm going to multiply this by 4a over 4a so that I'm able to put these together. When I do that, I'll have a negative 4ac plus b squared all over 4a squared. Now I'm ready to take the square root of both sides. Applying the square root property, don't forget your plus minus. Then you'll have x plus b over 2a equals plus or minus the square root. I'm going to rearrange these terms so that I have my positive first. B squared minus 4ac, and the denominator, you see I've shortened my radical sign here because the denominator comes out quite nicely. Now to isolate x completely, I subtract b over 2a from both sides. So I get a negative b plus or minus square root of b squared minus 4ac all over 2a. I could do that because they have the same denominator. And you might recognize this special equation. That special equation is the quadratic formula. So we can take any ax squared plus bx plus c equals 0, and the solutions will be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's solve this using quadratic formula. We already have it all on one side equal to 0, so we can pull out the a, b, and c. A is 2, b is 3, c is negative 7. Now I'm ready to put this all into my formula. So x is equal to, I've got a fraction, negative of b, so the opposite of 3, plus or minus the square root of b squared, that would be 9, minus 4 times 2 times negative 7 all over 2 times a, that's 2 times 2, and then the rest is simplifying. Negative 3 plus or minus the square root of 9 plus 56 all over 4. We can keep on going. Negative 3 plus or minus the square root of 65 all over 4. Now, the square root of 65 is 5 times 13, and there's nothing more that you can do to factor that, so we don't have enough prime factors to be able to take anything out. We're simplified right here. So x is going to be equal to negative 3 plus the square root of 65 over 4, or negative 3 minus the square root of 65 over 4. Now let's think kind of in a reverse way about what we've done. If we have a quadratic equation, x squared plus bx plus c equals 0, and this has solutions of 6 and negative 4, what are b and c? Well, if we're looking at solutions of 6 and negative 4, that must mean that we had x equals 6 and x equals negative 4 at the end of solving our quadratic equation. Now that we have that, we can work backwards. This must have come from x minus 6 equals 0, and this from x plus 4 equals 0. This is just thinking about what the zero product rule does in reverse. Now, the zero product rule would have said that this times this equaled 0. And now we're so very close. If we can go ahead and FOIL this, we'll have x squared minus 2x minus 24 equals 0. So what are b and c? b is negative 2, c is negative 24. Now you've seen that some of the solutions of our quadratic equations are not as nice as the examples we've had just before this. So here we have a quadratic equation, x squared plus bx plus c equals 0, that has solutions of 5 plus 3i squared to 2 and 5 minus 3i square roots of 2. Let's figure out what b and c are here. So working backwards, I know if it's a solution, this came from x equals 5 plus 3i square roots of 2, and x equals 5 minus 3i square roots of 2. The step that would have come before that is that each of these factors, x minus 5 minus 3i square roots of 2, would equal 0. X minus 5 plus 3i square roots of 2 equals 0. Now, this would have come from these two factors multiplied together equaling 0. That 0 product rule in reverse. X minus 5 minus 3i square roots of 2 and x minus 5 plus 3i square roots of 2. So I'm going to have 3 terms here multiplying 3 terms here. I'll end up with 9 terms in my expansion on that first step, just to know what to expect. X times x, that gives me x squared. Then I have x times negative 5, negative 5x. Then I have x times a positive 3i square roots of 2. That makes a positive 3i square roots of 2x. Now x here has multiplied everything in the second set of parentheses, so I'll move on to negative 5. Now, negative 5 times x is negative 5x. Negative 5 times negative 5 is a positive 25. Negative 5 times 3i square roots of 2 is negative 15i square roots of 2. Again, we're finished now with that negative 5 here multiplying everything. So we'll move to the last term here and multiply it through. I'll have a negative 3i square roots of 2x. I'll have a positive 15i square roots of 2 and a negative 9i squared square roots of 2 squared. And that all still equals 0. Now we need to just simplify. X squared, that's the only x squared term. I have a negative 5x and another negative 5x here. That'll make a negative 10x. I have a positive 3i square roots of 2x and a negative 3i square roots of 2x here that cancel out. Here's a 25. I have a negative 15i square roots of 2 and a positive 15i square roots of 2 that cancel out. And then I have this term here, a negative 9i squared times the square root of 2 squared. Well, remember, I squared is negative 1. So that negative 1 times the negative 9 is going to make this a positive 9 times the square root of 2 squared is going to be 2. So x squared minus 10x plus 25 plus 18 equals 0. We're almost there. X squared minus 10x plus 43 equals 0. So b is -10, and C is 43. The fundamental theorem of algebra for quadratics says that using complex numbers, every quadratic factors. We've seen in our first set of examples that we did have a quadratic that we said was prime. So let's figure out how we can factor that. Factoring using the quadratic formula. Now x squared minus 2x plus 2 does not factor using regular methods, so let's use the quadratic formula to factor it. So first we'll set this equal to 0 and then identify the a, b, and c. A is 1, b is -2, and c is +2. Now x is going to be the opposite of b plus or minus the square root of b squared minus 4 times a times c, and that's all over 2 times a. So now x is 2 plus or minus the square root of 4 minus 8 all over 2. That's x equals 2 plus or minus the square root of -4 over 2. That's 2 plus or minus 2i all over 2, which is 1 plus or minus I. So now, just like the problems before, I've found the solutions. I can make the factor from those solutions. 1 plus I would have come from the factor of x minus that solution, so x minus 1 minus I. And 1 minus I would have come from the factor of x minus 1 minus a negative I, and that is the way that we would factor x squared minus 2x plus 2. So just as a summary of solving quadratics, we can use this list as a way to get a quadratic solved. First, rearrange the equation to match ax squared plus bx plus c equals 0 and try to factor it. If factoring works, then set each factor to 0 and solve. Now if factoring doesn't work and b equals 0, then try to solve using the square root property. If the above methods don't work, then use either completing the square or the quadratic formula. Let's look at an application of a quadratic equation. In this instance, you are building a pet pen that's to be installed along your house. This plan will save you some fencing materials since one of the long sides of the pen will be the side of your house. You have 26 feet of fencing and need the area of the pen to be 84 square feet. What should you make the dimensions of your pen? So I start out with having 26 feet of fencing. I don't know the length or width of this pen, so I'm going to need to go ahead and define a variable. Let's let our W equal the width of the pen. If we let W equal the width of the pen, here and here, and if you can picture the sides of this fence being laid out here, we have 26 feet of fence. We have a width on either side. That means that this side, the length, is going to be 26 feet minus 2 of those widths. In other words, the remainder of the 26 feet of fencing will be our length. Okay, so our length of the pen is going to be 26 minus 2w. All right, I know also that I want the area of the pen to be 84 square feet. This means that the width times the length of 26 minus 2w is going to be 84, because I know that the area of a rectangle is length times the width. Now I have a quadratic equation I can solve. Let's go ahead and distribute the w. I'll have 26w minus 2w squared equals 84. Now it's quadratic, so my first attempt at this, I will try and factor. I'll need to get everything on one side equal to 0. So I'm going to subtract the 26w, and I'll add a 2w squared to both sides. When I do that, I'll have 2w squared minus 26w plus 84 equals 0. Now on to factoring. I have a greatest common factor of 2. I'm going to take that out. And then I have a trinomial to factor. Leading coefficient is 1, so I need factors of 42 that add up to be negative 13. That's going to be a negative 6 and a negative 7. So we have factors of w minus 6, w minus 7, and my greatest common factor of 2 up in the front. Let's come over here now. The zero product rule says now that each of those factors we can set equal to 0. But I know that 2 cannot equal 0. We just throw that out. And here I have a w equals 6. And here a w equals 7. So the width of my pen is either 6 or 7. Let's see which one makes sense here. The width of the pen, if it was 6 feet, then 26 minus 2w, well, 2w would be 12, and 26 minus 12 is going to be 14. So that would be the length of the pen, and 6 times 14, you put that into your calculator, you're going to get 84 square feet. Now, what if we had used 7 feet? If we use 7 feet, then this 26 minus 2w is going to be 26 minus 14, which is 12. So we'd have 12 feet. And we know that 7 times 12 is 84. So we can have either of these dimensions. We can make this a 6 foot by 14 foot, or we can make it a 7 foot by 12 foot. Let's double check and make sure that we'll have enough fence for these. The 6 is my width, so I would have 2 of those. That'd be 12 feet. And adding in the 14 feet of length, that's 26 feet of fencing. If I tried the other dimension, I would have 2 of the 7 feet lengths, and then I would add 12, and that is also 26 feet of fencing. So either of these dimensions are going to work. Now you may have seen the Pythagorean theorem before, but I'm going to review it here. The Pythagorean theorem is given as a squared plus b squared equals c squared, where a and b refer to the legs of a right triangle adjacent to the 90-degree angle, and c refers to the hypotenuse. Literally, this means if we take the length of one of the legs and square that number, and we take the length of the other leg and square that number, then it's going to equal, added up, the square of the hypotenuse. Now the legs always make up the right angle. That's what it means to be adjacent to the 90-degree angle. And the hypotenuse is always the longest side, and it's always across from the right angle. And it's not a leg. So let's see how we apply this. A manufacturer makes a piece in the shape of a right triangle. One leg is 3 centimeters longer than the other. The hypotenuse is 6 centimeters longer than the shorter leg. So how long are the sides of the triangle? Well, let's go ahead and draw a right triangle so we can start labeling. It does not have to be to scale. We just want to get our thoughts kind of diagrammed out. So we have a leg that is 3 centimeters longer than the other. And we have the hypotenuse 6 centimeters longer than the shorter leg. So it seems like that shorter leg is the thing we know the least about, and that's how we know what we want our variable to represent. We're going to let x equal the length of the shorter leg. And then we defined everything else on that. Let's call this one x, that shorter leg. And it says one leg is 3 centimeters longer than the other. So this will be this other leg, x plus 3. We're going to let x plus 3 equal length of the longer leg. Now, it says the hypotenuse is 6 centimeters longer than that shorter leg. Our shorter leg was x, so the hypotenuse is going to be x plus 6. Let's define that here as well. X plus 6 equals the length of the hypotenuse. Now we can put this into the Pythagorean theorem. A squared plus b squared equals c squared. A, b, you could also call this one a and this one b. That doesn't matter. But hypotenuse is always across from that right angle, and it's the longest side, and it's not a leg. So I have x squared plus x plus 3 quantity squared equals x plus 6 quantity squared. Now I can solve. I need to do some expanding here. I'll have x squared plus x squared plus 6x plus 9 equals x squared plus 12x plus 36. Now we can see we have a square. This is a quadratic equation. So I'm going to take some time and get everything on one side of the equation. If I subtract x squared from both sides, that'll give me just an x squared on the left. If I subtract 12x from both sides, I'll have a negative 6x over here. And if I subtract 36 from both sides, I'm going to have a negative 27. And now we have a nice, simpler quadratic that we can solve. I'm going to solve this one by factoring. X minus 9 times x plus 3 is what I'm looking for. And I'll have an x equals 9 coming from this factor equaling 0, and x equals negative 3 coming from this factor equaling 0. Now, let's go back to where we defined our variables because we still need to answer the question, how long are the sides of the triangle? We said x was the length of the shorter leg. Is x 9 or is x equal to -3? Well, we can't have negative lengths on legs, so we know it's going to have to be just the single answer of 9. So the length of the shorter leg is 9 centimeters. Now the length of the longer leg was 3 more than that, so the length of the longer leg is 12 centimeters. And the length of the hypotenuse is the length of the shorter leg plus 6, so we have 15 centimeters. Now just double check the answers that we've gotten here make up this right triangle of 9, 12, and 15. We know that all of those numbers fit into the variables we've defined as x, x plus 3, and x plus 6, but the numbers here should still satisfy the Pythagorean theorem. Is it true that 9 squared plus 12 squared equals 15 squared? Well, 9 squared is 81, 12 squared is 144, 15 squared is 225. And when I add 81 and 144, I get 225. And that checks. So we know we have a right triangle with dimensions of 9, 12, and 15.